All right, today we're going to jump into a really powerful tool from Precalculus, something that lets you add up huge lists of numbers in a flash, the Arithmetic Series. And yet it might look like a magic trick at first, but trust me, it's just pure, awesome logic.
So let me ask you this. How would you figure this out? I mean, you could punch every single number into your calculator, but wow, that would take forever. Doing it by hand? No way. But here's the cool part. By the end of this, you'll be able to solve this exact problem in like 30 seconds. Seriously.
So here's our game plan. First, we'll talk about what this summing challenge really is. Then I'll give you the two key formulas you absolutely need. After that, we'll put them to the test with some examples, cover the common mistakes so you can avoid them, and finally, we'll see how this math can actually show up in your paycheck.
Okay, so what are we even talking about? You probably know about an arithmetic sequence, right? That's just a list of numbers where you add the same amount each time, like 5, 8, 11, 14. You're just adding 3 over and over. Well, an arithmetic series is just what you get when you add all those numbers up. That's it. Simple as that.
Now, the good news is, to solve these big summing problems, we don't have to add every number one by one, thank goodness. Instead, we have two incredibly powerful formulas that do all the heavy lifting for us. Think of these as your secret weapons for this whole topic. Here's our first one. That S sub n just stands for the sum of n terms. N is how many numbers you're adding, a sub 1 is your very first number, and a sub n is your last one. It's so clever how this works. It basically pairs up the first and last numbers, the second and second to last, and so on. Each of those pairs adds up to the exact same thing. So you just figure out that sum and multiply it by how many pairs you have. And now for version 2. This one might look a little more intimidating, but it's our go-to when we don't know what the last number in the series is. The only new thing here is d, and that just stands for the common difference, the number you're adding each time. You know, like the 3 in our 5, 8, 11 example. So knowing which formula to grab is half the battle, and it's actually really simple. If you know where you're starting and where you're ending, go with Formula 1. It's fast and direct. But if you only know your starting point and the size of each step, that common difference, then Formula 2 is going to be your best friend. All right, enough theory. It is time to get our hands dirty and see these formulas in action. Let's start with something pretty straightforward, and then we'll crank up the difficulty. Okay, here's a classic problem. We've got a starting point, 5. We know the common difference is 3, and we know we want the sum of the first 20 terms. Now, since we know the difference, Formula 2 would work perfectly. But just to show you how all this connects, let's solve it using Formula 1. Of course, to do that, we first need to figure out what that last term is. So first things first, as you see in step 2, we got to find that 20th term. So we take our first term, 5, and add the common difference of 3 19 times. That gives us 62. Now we have everything we need for Formula 1. As you see in step 3, the sum is just 20 divided by 2 times the first term plus the last term, which gives us a final answer of 670. Okay, let's kick it up a notch. This time, we're flipping the problem around. We know the sum we're aiming for, 820, but we don't know how many terms it's going to take to get there. We're solving for n, and this is a perfect job for Formula 2. So we just plug in what we know. Our target sum is 820, our first term is 3, and our common difference, well, that's 4. When you start working through the algebra and get everything set to 0, you end up with the quadratic equation you see right there. We're not going to grind through the factoring here, but when you solve it, you find that n equals 20. So it takes exactly 20 terms to add up to 820. And here it is, the challenge from the very beginning. But now, you've got the tools to totally dismantle it. We know our first term is 50, our last is 150, and since we're just counting integers, the common difference is obviously 1. Since we know the first and last terms, Formula 1 is the obvious choice. But hold on, here's the most critical step, the one everyone gets wrong, finding n. It is so tempting to just subtract 50 from 150 and say it's 100, but that's a trap. As you see in step 2, the rule is last minus first plus 1. So 150 minus 50 is 100. Plus 1 gives us 101 terms. Now we're ready to plug everything in and solve. And there you have it, 10,100. That's the sum of every single number from 50 to 150. Pretty amazing, right? This shows you just how powerful these formulas are. No mind-numbing calculation needed. All right, let's quickly talk about how to avoid some of the common mistakes. Honestly, knowing where students usually trip up is the best way to make sure that you don't. Okay, here are the two big ones. First, like we just saw, never ever assume the last number in your list is n. You have to actually count the terms. Remember the rule, last minus first plus 1. Got it? Good. And second, if you want to use that fast, slick Formula 1, you absolutely must have the last term. If the problem doesn't just give it to you, your first job is to go and calculate it.
So you might be thinking, okay, cool trick, but why does this matter outside of my math class? Well, these patterns are everywhere, especially when you start looking at money that grows in a predictable way over time.
Just think about this classic scenario. Your salary goes up by the same amount every year. Well, hey, that's just an arithmetic sequence. Your first term is $50,000, your common difference is that $2,000 raise, and n is 10 years. We have everything we need to calculate your total earnings over that whole decade. And would you look at that? $590,000. By using the Arithmetic Series formula, you can figure out on about 10 seconds what you're going to make over a decade. This is way more powerful for planning your future than just looking at a single year's salary, right?
So, I'll leave you with this thought. Now that you have this new math superpower, where else can you use it? What about a savings plan where you decide to deposit a little bit more each month? Or a workout routine where you add 5 more push-ups each week? The world is absolutely full of these patterns, and now you've got the key to unlock and calculate them.